Today I'm going to show you how to create a GUI using SwiftForth. And today we're going to create a simple little program that will track our mouse movement in real time. So to demonstrate this, I'm just going to left click the mouse button, which will activate the program. And as you can see, it's tracking our mouse movement in real time. And to kill this program, all I need to do is hit the spacebar or any key, and it will stop or pause our program right where our mouse left off at. So we can use this to troubleshoot mouse coordinates. And if you don't remember the second video I did, we automated clicking buttons using Windows API calls. So if you're not familiar with that video, check out the second video I did. But I will run a sample program that I did from that video. And all this program does is it opens a calculator app, and it's going to move our mouse to these X and Y coordinates that we have right here. It's going to wait 200 milliseconds, and it's going to click the mouse for us. And it's going to move on to click the plus button, to, and the equal button. So let me run this. So as you can see, this program clicked the buttons for us, but we had a misfire. And it didn't click the button 1 properly, so it missed. So we can use this program that we're going to create to troubleshoot this. So I can activate it, and we can move our mouse over the 1 button, and we can, hit the space bar, and we've got our X and Y coordinates. So we can take these two numbers and replace them right here, and we should be able to click, the 1 button. So that's kind of what this program does. It's the mouse position helper. So if that's something you're interested in building, stay tuned and I will get things set up. So to explain this better, I put together a slide that shows what happens whenever you click the mouse button. You open your program up, and if you click your mouse button repeatedly, you will generate these messages. So in this case, we're generating these WM left button down messages. These are Windows messages that get generated whenever you click your mouse button. So there's other Windows messages. Another main one is if you press the keyboard, you will generate these WM key down messages. So that happens whenever you press a key. And another message, by the way, these are 2 hardware messages that are generated by the operating system. But there's also another one, which is if you resize the window, you are generating these WM paint messages. So that message is not necessarily hardware generated. So you've got kind of these 2 types of Windows messages. You've got the hardware triggered messages and the software related Windows messages. So to see a full list of Windows messages, you can go to this website. I will link it below. But as you can see, there's quite a few messages that get generated by Windows. And as we saw before, there's the paint message that gets generated whenever you resize a window. The WM close message happens whenever you click on the X in your program. So that would be, for example, this button right here. If you click close, that actually generates a WM close message. So that's what generates that. This is also related to that WM quit. And what we were dealing with was the left mouse button. So as you can see, whenever you click the mouse, you generate this message right here, the left button down. And you also generate a button up message whenever you release the mouse button. And you also have the right mouse and you have the mouse wheel. So you can actually capture these messages that are generated by Windows and you can do something with it. So I will show you that in the next part. And if you want a deeper understanding of how Windows works under the hood, this is a graphic I found. I think it illustrates it, how Windows pretty much works. For example, if you click the mouse button, what you're actually doing is you're generating this WM left button down message, or actually the operating system is generating this message. You know, after you click the mouse button, it goes into a message queue, which we don't have to do in SwiftForth. And then it goes into a loop. This is usually a while loop, or they call it a message loop. And this message loop is constantly running a get message command. So it's constantly calling this function called get message, get message over and over and over again. And like I said, these are the messages. So it's always trying to grab these messages in this loop. So after it grabs, you know, this message right here for the button click, it'll grab the message and it's going to dispatch it. So it's going to send it somewhere. And usually this somewhere is a switch statement, which we have to program ourselves. And that's the part I'm going to show you. So let's build the most simplest GUI that you can possibly make. This is the minimal code that you would need to run a basic GUI. It looks a bit complicated, but really the only part we need is this switch statement. That's where we tell the GUI what to do if we receive that message. So if we receive a WM left button down message, then we need to capture it in this switch statement and we need to do something. So most of this stuff is just setup code, and it's you can pretty much just use it as a template. But all we're doing really is messing with this switch statement. That is kind of the heart of this whole program. This other stuff I will probably cover later in the video, but the main part, if you want to just get to programming a GUI, is you just mess with the switch statement. And maybe you would, change the dimension of your program. This is kind of where you would set the size of the window. So let's just copy and paste it in. And to run it, we have a start right here. So all we need to do is just hit start. And it's going to generate our basic GUI. So as I said before, if we click the mouse over it, it's not going to do anything. So we have to program that in this switch statement. So the question is, how do you do that? So all you do is you put in your message that you want to capture, which is left button down. And then you type in run, and then you got to tell it what you want to run. So what you can do is you can, put in your code here, and you're going to, just fill this out. And you always want to put a 0 because this switch statement is expecting, or it wants to, output something. So in this case, just put a 0. And that's pretty much the format you would use so we can start to build something out And what we're going to do is we're going to build a message box. So the code here, we're just going to type in HWND, hello, and ebox. So we can actually test this out. If we just type that in, we should get a message box that says hello. And if you want to see how this works, you can type locate ebox. All it is a message box. And it's expecting this is called a window handle and a 0 terminated string. So anytime you want the window handle, you just type in HWND. So this is already built into SwiftForth. There's no need to program anything else. It'll just spit out a handle. So all we need to do is, just copy and paste that in right there. Add your 0 at the end, to make this work correctly. And we can see if this will work. Wipe the screen. And I may have to close this out because we probably need a new window. Start. And if we click anywhere in this area, we should get our message. So sure enough, we do. And what we can do is we can start to capture those messages. So you can go back to that list I showed you. But we can add the right button or the right mouse down button. And we can have it, let me do this again. Just copy and paste that in. Change that to right. And we'll have this say something, like that. So we can copy and paste this in. Let me get a new window. And here we go. So we got hello. And we got the right mouse button rigged up. So you can start, programming the messages. And next I'm going to show you how to draw to the screen or draw to the GUI, which involves, painting and doing things like that. So I'll get that set up. I've added 3 words, or I've added 3 things to our code. What we're going to do is we're going to build this string out. So that's what the word is called, build string. So we're going to build our string. Next, we're going to show it. We're going to show the mouse coordinates. And the main word that does all the work is draw text. So that's the whole word that makes it output to the GUI is draw text. Anytime you want to put text onto a GUI, you're going to use draw text. And down here, I added this so that whenever we click the left mouse button, it's going to show or draw our text to the screen. So let me copy and paste this in. Type in start. And if we click our left mouse button, you can see that we have drawn our text to the screen. So what I'll do next is I'll cover line by line how this code works, and you'll understand how it's able to do that. So when you look at this code, again, the main thing to look at is that we are capturing, like I said before, that Windows message. In this case, the message is our left mouse button, and we're going to run something whenever we receive that message. So usually when you look at this code, you're always going to look at the switch statement first. That's where you should look. And then after that, you can kind of follow along a lot easier. So when we receive that left mouse button click, we're going to run. And we're going to run this code, which is get DC show string. So show string is up here. We're going to run that. But before we do anything more, we're going to build the string. So we're going to come up here and we're going to build, all this stuff right here. And then after that's completed, we'll come back down here. We'll center our text. And finally, we will draw it. So that's kind of the order that it's going in. And once you understand the order, you can kind of follow along a lot more easy. So the next thing is, how does all this other code work? Because it looks kind of probably like a foreign language if you're not too familiar with programming Windows API stuff in SwiftForth or the Forth programming language. So I'll cover this real quick, or I'll actually go in depth about how all this works. So we know the order, and basically all this code is centered around this word called draw text. So if we pull up this word in the Windows documentation, we can see that this word has a few things that it requires in order to draw things to the GUI. First thing we need is a handle to a device context. That's what HDC stands for. So to do that, Windows has another function, is get DC, supply it with a window handle, and the output will be a HDC. It'll just be a number. So that part is taken care of in this section right here. And the next part is we see that we need to build our string and get the length of that string. So all our building is done right here. So I will actually, what I'm going to do is delete this so you can probably get a better feel for how this function really works. And we will just build this string using just one line of code so you can see like how it really works and why we do this. So what we need to do is we've already got the first part. Next part, we're going to draw this piece of text to the screen, hello world. And if you're not familiar with this, when you just type it like that, it will output an address which contains the string, and we have the length of the string. So it will do that work for us. So we've got that part covered. Next part, we will get the dimensions of the client rectangle. And that may seem, kind of confusing, but what is the client rectangle? Well, it's this area, this black part right here. That's the client rectangle. Is this, this section right in here. That's where, all the action happens. So in Windows terminology, this is called the client area. So that you'll see that a lot. So how do we get this? Well, there's a function called getClientRect. We need to supply it the window handle, and we need to dump this into a address location. In this case, we're going to dump it into pad, which is our scratch pad of memory that's built in. And that's all we need to do. So it's going to, dump all that information in there. So we can type that in. And we have to pay attention because this does output something that we don't want. We don't want that flag. It's going to output a true or false flag. We're just dumping the client dimensions into this data space called pad. So that's all we want to do. We don't want that flag on the data stack. And next, we need our format. So we need to tell it that we want it to be, center and single line. So I'm just going to copy and paste from that program. And that's how you build this this out. Is you want to OR things because it's kind of like a bit mask. And you can actually, run this to see what these values are. So if you, just type it in, you'll see that this is 32 and 1. And if you OR these together, you're going to get 33. So it's kind of like a bit mask, and you can just keep ORing things together, and that's how you get your format. So finally, I think that's all we need. Actually, we need to supply, or we need to drop that, because like I said, we just want this to put the dimensions in here, drop it, and we need to supply that address again, so that this, this is supplying our address, or this data space is supplying, that information. So after all that, we can finally type in draw text, and that should write hello world to the screen. And you can see it's kind of a lot of work, but let's see if it'll work the first time. Start, and there we go. So we got hello world drawn to the screen, and you can see that it's quite a lot of work to get there. So that's why we usually split things up and make it easier on, just for readability. So I will, copy and paste that code that we deleted, and you can see that all this stuff is kind of, in the same format. We're just splitting it up so that we can, create our string, and it's much easier to read. And the next part, I'm going to cover, how to build the string, because this is a little confusing as well. Next, we're going to cover these words that we use to build the string. So what we can do is we can actually type this into SwiftForth. And as you know, or have seen in my other videos, this word mouse position outputs the X and Y coordinates to the data stack. And if you didn't know what that word did, you would type in locate and the word, and the kind of source will show up. So it says right here that we have the X and Y coordinates that are going to be outputted. And the next word we have is this one, parentheses with a period. If we just type that in, it's going to convert that string, or that integer, into a string, which we can use this word type, which will print the word out onto the terminal. So again, if you didn't know what that word does, you can just type it in, and it will show you that it's going to convert this word using you may have to go a little deeper and type in this word, and it will show you that this is kind of the way you would convert integers to strings. Is anytime you see this, you know something is going to be converted. So that's how you do that. And so we will cover this next part, which is going to be here. And we're going to place that string. Basically what this is doing is we are placing the string into a data space. So instead of here, we can use the word pad. So we can type in pad, and we can type in place. And what it will do is it will place our integer, which was converted to a string, into this data space called pad. So what we can do is we can do pad count. And as you can see, it counted 3 bytes. And it saved our number, which was 426. Now, if I dump this 10 bytes of this data space, you can see that it saved the length as the beginning part, and it saved our string as the next part. So that's kind of how place works. And it's more, I think it's more efficient to use this type of way instead of the zero counting. I'll have to look at the documentation, but I believe that this way is pretty efficient whenever you use place instead of just zero terminating things using zplace or something like that. So we know how to place strings into a data space using the word place. So of course, the next thing that you would learn is how to append to that string. So what we can do is we can append things. And what we can do is to just use pad again and to place that string in there. So our string is now in there. And what if we want to append something? Well, you can use the word squote, and you can append any type of text following that. You can just type in hello. And again, that's going to convert it into, it's going to give you the length and an address. So what we can do is we can append that. And let me just look at this real quick and we got the length. Now we need the to, which is the address we need to append this to. So we're going to append this to the pad address, which is our scratch pad memory. And all we do is hit append, and our text is now appended. So we can dump this. I'm going to dump 20 bytes. And you can see that our number was put in there, followed by our text, which is hello. And the way pad works is it's a temporary data space, so it's always going to have extra junk inside of it. So anytime you use pad, it's always recommended to, erase it and do things like that. So you kind of don't have this extra stuff in there. But you can see that we are placing strings and we are appending them. So that's pretty much all we are doing here. And then we're getting the count, which, as I said, is placed at the beginning whenever you do these strings. So that's pretty much how you build this string. If you have any questions, I can answer them below because I kind of went a little bit fast, but that's the basics of how you do this. So in the next part, we will cover how to paint. So with our code, let's go ahead and run it real quick to see how the paint function is going to work. I'm actually gonna just open a new window. We'll copy and paste that in and type in start. And we can see that whenever we click the mouse, it will draw to the screen. But there is an error because if we resize this window, we notice that it just disappears. And to fix this, like I said before, that's kind of how what we have to do is we have to repaint the screen, because this is kind of one of the things about Windows programming is that you're going to be required to, paint the screen again and again and again. So what I was trying to do is trigger this error right here. Is you can see that there's, even though we have a 1 up here, whenever we click up here, there's still this artifact that's left over. So and we have this messed up right here. So that's kind of why you have to repaint the screen, is you're going to run into errors like this if you don't. And also if you resize the screen, your text just disappears. So you have to have a way to fix that. And that's what I'm going to show. To better explain this, I pulled up an article from Code Project that says how to draw text in a Win32 project window, which is what we're trying to do. And this person basically had the same problem we did, which is when you call draw text, you're also generating this WM paint message. And the two kind of, you have to balance the two. It's kind of a tricky thing. So down here, they give a solution, which is what we've done. We've pretty much done this part so far, which is to get DC. We dump this into a pad, a data space. We got the dimensions of our client area, and we drawed a piece of text. And it says that if you try to move the window, change its size, or move another window over it, you'll see that your text is no more there. It's gone. And it says, because when you modify or do any type of stuff like that, you'll generate a WM paint message, and that has to be handled. So you have to do something with it, and you have to repaint that area. That's the key, is you have to repaint what you've drawn. So the effective way is to basically, you can read this right here, and it gives steps, but the main thing that we're going to do is we're going to deal with begin paint and end paint. So you can see they have a sample program, and the main thing to look at is you got to have this function, and you got to do your draw text in between those two things. So that's really the only change that we have to do, is we have to sandwich it in between begin paint and end paint. I've added the following code to our program, which is refresh and repaint. So we've added these two things to our code. And in addition, we've appended this Windows message, which is to handle that WM paint message. So you could also, if you wanted to, you could move, this up here and do it that way. But SwiftForth provides a way to append switch statements onto like your main one. So that's how you would do it, using this kind of plus symbol. And I also added the refresh right here. So that should fix the errors that we have, and Let me just run this real quick. And as we can see, we are able to get our coordinates. And when we resize the window, we are also, sending out those WM Paint messages. And you can see that our coordinates are also changing. So if I, click up here and click down, below, you don't see any artifacts that are left over anymore. So those artifacts are completely gone with this WM Paint message. So we can resize the screen, and we're basically erasing and repainting. I mean, really, really fast. So in the next part, I'll cover how this works. I'm going to cover the order that we are going to do this in. So for example, if we resize the screen, we're going to receive a bunch of WM Paint messages that come one after another. That's going to run repaint, which is up here. We're going to begin paint, get the client dimensions, and we're going to run up to show string. Before we show string, we're going to build it. So that's just building, that's converting the mouse coordinates from integers to strings. Come back down here, get the client dimensions. We're going to center it, and we're going to draw text. And after that, after we've drawn the text to the GUI, we just end. We end our painting. So that's pretty much what it's going to do whenever you resize the screen. And in the next part, I'll cover what this does, because this is actually a separate thing. Next, I'm going to cover line by line how we fixed the other issue, which is we had those artifacts whenever we clicked, our left mouse button, it would leave like the letter 1 or the number 1. It would stay drawn to the screen and it wouldn't erase. So to actually fix this, what you need to do is you need to call this word refresh. And what this will do is it will erase the screen by calling this, which is invalidate rectangle, or you can think of it as invalidate client area. And when this is set to true, that means it's going to erase that client area. If it's set to 0, I believe it will just keep drawing and you'll have those artifacts. So this has to be set to true. So whenever you run this, it actually generates a WM Paint message. So we're going to come up to repaint. We're going to begin paint, get our dimensions. We're going to show string, build string, convert, our ints to strings. We're going to center that, draw it, and come down here and end. So that's basically how we fix it, is we just have to refresh the screen, which will trigger this, which will, draw our thing to the window. And that's pretty much how it works. So I'll just run it again. So we got that. So right here, we're receiving, a bunch of WM Paint messages. So we're drawing the coordinates to the screen. And right here, we've got the same thing going. And no matter, if we resize it and, click around, we're not generating those errors that we had earlier. So that's pretty much how this works. And real quick, I didn't really cover this, but this is how you would append a message to your main switch, is you just put a plus and then you just, define what, you just match these two things up right here. So that's how you kind of append to a switch statement. The next thing is, where did I get those? Where did I get invalidate rect? It's part of the Win API. You can read it about it here, but that's pretty much what we did is we erased the client area. And the next thing we did is we did begin paint. So all these things are in the Windows API. Now I'm going to show you how to create a real-time mouse tracking. Since we've built everything up until this point, if you're not familiar, you can go back to the beginning. But basically, whenever I hit the space bar or any key, it's going to pause the program. And clicking anywhere in the client area is going to restart it. And the right mouse button will stop it. But if we do the right mouse button outside of this client area, it won't stop the program. It will just put this other window into focus. So that's why we have our program looking for these WM key down messages so that we can stop the program outside in this area. So here's the secret to how this works. What we are doing is we are setting a timer. This is a Windows API thing that you can do, and it's going to go off every 10 milliseconds. So every 10 milliseconds, this will generate a WM timer message. And we are actually capturing that timer message. And what we're going to do is we're going to refresh the screen. So we're going to come up here, we're going to clear the screen, and we're going to draw our mouse coordinates every 10 milliseconds. So that's pretty much the secret. And to kill it, we just call kill timer. And this right here is just a unique ID. You can put anything. You can put 1, 2, 3, but it has to be a unique ID, and you have to match them all together. So this allows you to set multiple timers, and that's the important thing to remember. So this is 10 milliseconds. You could put 100 milliseconds if you wanted to. It'll just cause it to, register these messages a little bit slower. So that's the key to this, and that's how this works. To learn more, subscribe to my newsletter. I've got it up on Gumroad. Just type in your email and hit subscribe, and it will add you to my list. And I have tips and tricks on that newsletter. Next thing is if you want to learn Windows programming, I highly recommend this book. It's an older book, but it really explains how the Windows operating system works at a low level, and it covers the message loop and all those little things that I kind of rushed through. But I guarantee if you read this book, even just the beginning, probably the first 1 or 2 chapters, it really explains how all this Windows stuff works, and it's pretty much how I got my start.